Okay, I'm going to show you how to use Desmos for this. I do want to let you know in your homework you are going to have to insert a picture of the equations and the graphs into your homework. So if you want to do that and you're in School Learner, you can just take a picture of your TI-84 or you can use Desmos. On the test, you're not going to have to submit any pictures, but you will need to know on the test how to use your handheld calculator, the stat, and the edit feature. But for any at-home learners, I thought maybe you'd make sure we know how to use Desmos. So let's see here. We have the table showing the U.S. shows the percentage of U.S. labor force in unions for selected years between 55 and 2005. We are going to let 1900, that's going to represent x equals 0. So this is actually going to be 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and 105. All right, now what we're going to do is I'm going to teach you how to put this information onto Desmos. Hey guys, just so you guys know, I'm recording. I don't care if your voice, it doesn't bother me, but I just, anything you say might get picked up. I don't think it will, but I just want you to know. All right, so to put this on a Desmos, what we're going to do is I'll do a split screen so I can actually see it. Down the x-axis is 55, 60. And I do believe they all count by 5, so what's nice about Desmos is that when it notices a pattern, you can just go all the way down to 105. Or you'll have to type in by hand. It doesn't really matter as long as you're able to do it. You guys can take off. I'll see you later. Have a good day. All right, now in the Y column, we'll do 33.2, 31.4. Oops, sorry about that. 31.4. Now, if you're in a handheld calculator, you're going under Stat and Edit here. 28.4, 27.3. Let's see, 25.5. I don't think they're all in there right. 21.9. But this is fun, watching me type this in by hand. Hopefully, maybe you're trying it on your own. I do notice that these are decreasing. 14.9. I would ask that you do this with me. As much fun as it is watching me struggle my way through this. All right, I think I got them all in there. I'm just going to double check. 33, 31, 38, 27, 21, 18. Okay, I think they're all good. Now, what I need to be able to do is I'd like to actually see this. So I'm going to talk to you about my domain, what I'm going to let my x-axis be. All right, so remember, I'm going to start on 1900 and I'm going to go up to 2050. So 1900 to 2050. So that means my x-axis is going to start at 0 and it's going to go to 150. I'm going to change that here in the settings wheel. X-axis, let's see, 0, and I want to go to 150. You can go up higher if you want to. I just want to be able to see all my info and then be able to predict the future. Let's talk with the range. So this is the percentages. So what I'll do is I'm going to go from 0 because we know we can't go lower than 0. And the highest percentage I see is 33. So what I'm going to do, guys, is I'm going to go to 50. So that range is going to be 0 to 50. Just using my numbers to kind of guide me. All right, there you go. And if you really wanted to, on your x-axis, you could even put a label on there saying year. That is kind of nice about Desmos here. Let's see when I'm going to have year and percentage. So if I want to, I could type year. I'm going to have to get my keyboard up. Let's see if it takes year. There we go, percent. How'd that take? There we go, that looks nice. Now what we're going to see is, there we go, we have all our points. They're looking really good there. What's nice, FYI, about Desmos is you can export this graph if you ever wanted to. I just wanted to show you that. You can even create a login and the sign up if you wanted. Now what I'm going to do is I'm going to kind of ignore the directions that are written here. But I'm going to come up with different models. I'm going to come up with a linear model. That's y equals mx plus b. And I'm actually going to use the approximate side. Quadratic model. Remember, you can do this all on your handheld calculator by going to Stat over to, after you type in your list, you can go to Stat and then Calculate. I'm going to find the cubic. And I'll also find the quartic. I have enough points that I can do all of those, so I'm going to. Remember, quadratic is ax squared plus bx plus c. Remember, cubic is ax cubed plus bx squared plus cx and then plus d. And quartic is ax to the fourth plus bx to the third plus cx squared plus dx plus e. All right, so bear with me. I'm going to find each one of those on Desmos. And again, you can do this in your handheld calculator, actually probably a little bit easier than Desmos, but I need to make sure I address every type of learner here. So I'm going to do y, I'm going to do an approximate sign, m, x sub 1, and this actually needs to be y sub 1, that's right, because it's pulling from the chart. So you're saying, hey, pull my y's from my y1, pull my x's from my x1, and then plus b, okay? And what you're going to notice is I'm going to cheat, because all math teachers are cheaters, right? There it is, boom. There we go. I'm gonna just save that real quick. Save it to my photos. I'll put it in Nobility in a second. Notice this r squared is actually really nice. Look at your downward trend of your line. That looks really good. Let's do quadratic now. Almost the same thing. So y sub 1. And we're going to do an approximate sign because it's not equal. Gotta hit to the side. A x, let's see, x sub 1. Okay, and then let's say we're in quadratic model, so it's going to be squared plus bx sub 1. Be patient while I work this out. I'm hoping you guys are doing this with me, but you know, can't stand over your shoulder, so that's my hope. Plus c. Look at that, r squared. R squared is really good there too. You can see a beautiful fit of that blue line. All right, now what we're going to do is we're going to go down to the next one. So it's the quadratic. I'm actually going to screenshot that. There we go. Quadratic model is there, my data. Okay, now we're going to do the exact same thing. I wish there was a copy paste. Maybe one of you knows there's a copy paste and I don't. If any of you figure that out, let me know. That'd be great. Okay, so now we're going to do the cubic. So we're going to do a x sub 1. We're going to do that to the third power plus b x sub 1. And that's going to be squared. Again, please remember how much faster this is on a handheld calculator. I would have already been done by now. I already have A, B, and C. But again, need to take care of all types of learners. And then C, X, and then a plus D. Oh, and that needs to be sub 1. There it is. All right, let's do that. Again, you can see the lines graphing as we go through, which is kind of nice. You can see how they fit and what they do. Save to photos. All right, I'm going to do one more, guys. I'm going to do a quartic. Ready? Y sub 1. And we're doing an approximate sign. Remember, your calculator would already have this all done. AX sub 1. I keep forgetting about that. Sub 1s. I need it to pull from that list. This is going to be to the fourth power. Plus B x sub 1. And that's going to be to the third power. And then plus C x sub 1. That's going to be squared. We're almost there. Plus dx sub 1. Pull your x's from that list. And then plus e. Okay, I think we got it all. There it is. Okay, I'm going to go ahead and do another screenshot. And what I would like you to do, look at the r squareds. Every time we do an r squared, do you notice that the higher degree, the more accurate r squared becomes? And that's simply because of the nature of, well, math. All right, so now I'm going to go back to Notability. Let's see here. Let's move everything down here. Oops, not that. Oh, you think I would edit this out? That's not going to happen. There we go. Let's do the linear. Boom, boom. Where's my linear model? I think that one's right. It was my first one. It's probably that. Probably that one. Is that my linear model? No. That's from my last item I had. There we go. Now we're cooking with oil. Here it is. I think it's this one right here. All right, there's my y1. There's my y equals mx plus b. Here's m, and here's b. Let's move this stuff down. Quadratic. Be here, quadratic. That is. And then remember, this is the number in front of x squared. This is the number in front of x. This is the constant. Doing great. I like how I just encouraged myself. That was really for you. I do think I'm doing pretty good, but the encouragement was for you. All right, there it is, guys. So we have all of our equations. If you wanted to rewrite it, you definitely could. Just remember, this is the number in front of x to the fourth. This is the number in front of x to the third. This is the number that would be in front of x squared. Oh, bummer sauce. It looks like I cut that one off. Let's hope it's still there. Desmos. It is. Boy, don't I feel kind of foolish. Where's E? I guess it's not going to show us E on Desmos. That's kind of sad. Huh. Okay. If you ask me where E is, I won't be able to tell you. So sorry. All right. Now, oh boy. Oh boy. Here's what we'll talk about. Let's talk about our points, and let's actually let's just let's just do this. We know which one's which. My goal in this video was to teach you how to use Desmos. I don't know where E is for the cortex, so right now my answer is don't worry about it. Okay? There it is. When we look at this data, we kind of have to estimate like interpolation or extrapolation, like which one do we think is best? So it says, what's the average rate of change if we wanted to answer this between 1955 and 1965? Well, you could just like, find the rate of change. Make a scatter plot. We did that. What kind of polynomial seems to be the most appropriate? In my opinion, they're all pretty darn appropriate. What I notice is that, like, when you're talking about predicting the future and stuff, I kind of feel like these two are out of it. Like, I think that was the cubic and the quartic models. Those two, it's like they increase so exponentially quickly, and then over here they decrease so exponentially quickly. I would have to tell you personally, I feel like the cubic and the quartic are not good for extrapolation. However, because the R squareds are so good for these two, I personally believe that I would personally say that the cubic and the quartic, I think those are the best for interpolation because look how close knit they are to all those points inside of there. But I would say that those are really not good for extrapolation. I forget which color is which. Let's see, linear is green, quadratic is blue. So I really like the quadratic model because I like how the quadratic model kind of comes down and it kind of levels itself off a little bit, whereas the linear just continues this downward descent. But I'm going to have to go ahead and say that the linear and the quadratic are really excellent models overall. If you only had to pick one, I would pick one of those two. But if you look, I would say probably, in my opinion, the linear, the quadratic, I'm pretty happy with both of those determining the future. I might go with the quadratic for the future and maybe the linear for the past. But what you need to be able to see is that while some are better for interpolation, others might be better for extrapolation. And like just reasoning those things through is very important. You always want to look at your R squared. The better the R squared, the better the fit, at least for interpolation. But then look at these. These are also really good predictors. Now, overall, mathematically, the quartic is definitely the best overall mathematically. However, when we think it through logistically, I don't see this chart. This trend that I see doesn't necessarily fit the cubic or the quartic because those explode at the end. So yeah, just being able to determine them, making a really good domain and range value so you can see your points, I think is pretty important. And that should be enough to go ahead and get you through 5.8 part 2. Again, if you're in school, being able to use that handheld calculator, remember you go to stat, you edit your list, and then you can go over to calc. And it's a lot faster than using Desmos. You can just pick linear, then you can pick quadratic, then you can pick, and so on and so forth. So I really like those. And you should notice as long as I did everything right, when I type things into Desmos, they give you the exact same values. So that handheld calculator is really nice, but I want to make sure everybody knows that Desmos is possible to get an answer. And that's all I got for you.